Welcome everyone to the Analytic Mind podcast. Got a really great guest with us today, Aleksandar Lazarevic and Lazarevic. Sorry, I think I got it right the second time. I'm sure you can give us. Yeah, it sounds Serbian to me. Is that would that be right?
Serbian,
Yeah,
yes.
yeah, nice, cool. Well. I can safely say that we've got a heavy hitter on the podcast today. Someone who's got a PhD, which is pretty amazing. Worked at a variety of large organizations over a number of years in the analytics space, but also experience in predictive analytics, machine learning, AI. So I can't wait to dive into a lot of those aspects of your experience. But you've also written a book and a number of articles in the analytics space. So much we can go into. So why don't I just throw it to you, Aleksandar, and then you can give a better overview of sort of your background and some of the things you've done, and then from there we can dive into some aspects of what you're doing and your expertise.
Okay, sure. Thank you. It's my really pleasure to be here. Thank you for inviting me to be a part of the great podcast. My name is Aleksandar Lazarevic. Currently, I'm a VP of Advanced Analytics and Data Engineering at Stanley Black & Decker. A little bit of my background is I came to US maybe more than 20 years ago. As a kid, I always liked math and the numbers. When I was growing up, I started to actually convert some of this love into computers and programming. I studied computer science, computer engineering. And when I had an opportunity to come to the United States to complete my PhD, or for my PhD studies, actually, there was a completely new field at that time. It was called machine learning. It was described to me as using the data from the past to predict what will happen in the future. And that whole concept was so amazing to me that I actually kept doing this since then. So for the last 23 years. I am actually right now at Stanley Black & Decker. We actually have much more things than people are aware. For people who are not familiar with Stanley Black & Decker, we have much more than the tools company. We have a storage business unit. We have healthcare. We have security. We actually number 2 in market share, just right after ADT in US. We have fastening and rivets. We make different kind of fasteners for different kind of industries, from cell phones to automotive market. We have oil and gas pipeline. We have we have actually aerospace manufacturing. We recently acquired that company. We heavily invest in robotics and automation in manufacturing. So that gives us really opportunity to work on different problems. Since I'm leading the centralized analytics organization, it gives me really opportunity to work with many of these companies to work on different kind of problems, ranging from demand forecasting, inventory optimization, pricing initiatives, customer acquisition, customer churn, trying to do e-commerce analytics, trying to understand our customers a little bit better, marketing analytics, just to name a few. So basically this, by kind of having all these opportunities to work with actually different kind of business or different kind of the problems, my whole passion to actually work with data gives me the full kind of fulfillment, and actually to help the business across multiple domains, really. That's basically, I love what I do right now, and I'm really looking forward every day to work on different problems that we experience.
That's great. I mean, I loved how you went through all those examples, because it just shows you the immense possibilities, or opportunities rather, like to actually make a difference in this particular area. Like all of those like inventory optimization and demand forecasting. I mean, these are things that can add significant value to how decisions are made and how an organization performs. So it's great that you're able to reel off so many of those examples. What would be interesting is, and also I knew that Black & Decker was more as sort of like a conglomerate, but I didn't realize it sort of reached to those sort of levels. I mean, it's just humongous, isn't it?
Yeah, actually, I didn't know before I started to work with Stanley Black & Decker. When first time was I contacted by a company to see if I'm interested. I went to their website, and I was really shocked by how many companies are there. We actually have around 25 to 30 companies within one big company that we make different kind of products and services, and we offer to our customers.
Yeah, amazing. Now, You did mention a lot of things there, right? And so my sort of question is, how are you engaging your um, abilities to these particular problems? Like, are you coming in and just sort of showcasing, okay, this is what can be done, and then you're moving on to the next thing, or like, what part of the process are you working on, especially in the sort of advanced analytics space? Like, are you doing the entire project? Are you like specifically working on the algorithms? Like, what are some of the things that you're involved in?
That's a great question, actually. And every organization has a different approach how to actually do analytics. What we are trying to do, the reason we are called advanced analytics, we typically like to do more advanced stuff rather than just creating the dashboard. And what we are trying to do really, main thing is to try to create or change the mindset in the business people. In my opinion, having a proper relationship, a proper partnership with the business is to show the value relatively quickly, build that kind of trust and credibility. And in my opinion, working effectively and with the business and having commitment and dedication on the business side is a key to every successful analytics project. Very often, initial thing that when we start talking to business partners regarding different kind of problems, the very first thing that came to their mind is actually, can we create a dashboard for something? But the dashboard is typically just describing the current situation. It's not necessarily resolving the business problem. So basically, trying to walk them to the process, how to think from the dashboard perspective to more like doing predictive and prescriptive analytics is the key, what we're trying to do, and provide more like advanced solution around machine learning and AI. I can give you an example around the customer churn. When you start talking about people who in our security business who are considered or actually who are concerned about customer churn, they would typically like to see, okay, what is our customer churn rate? How much money we are losing there? How many people or how many companies leave us? And instead of doing that, and instead of doing this kind of KPIs, the key thing is actually what companies are most likely to leave us? What is the likelihood behind this? What we can do to proactively reach out to them and convince them to stay with us. So this is kind of the typical process that we try to do when we work with your business and try to actually change that kind of mindset, how they think about analytics problem. Because one thing is to actually look at things in reactive way, and another thing is to look at things in a proactive way. And the whole purpose of having advanced analytics, predictive and prescriptive, is actually to provide some kind of recommendations based on data and using advanced analytics, machine learning, and AI. This is what we typically try to do.
Nice. Now, what? Because I really like the concept of quick wins or like showing value quickly, and because you get to work across such a diverse range of sort of even industries and I presume business functions as well. Do you find that any one area is more receptive, or it's easier to generate value in one particular area versus another? It'd be interesting to get your insights on that.
You mean particular part of the business within our company?
Yeah, like do you feel like you can generate more value in, say, like a consumer goods industry versus, say, like the aeronautics, like the aerospace industry? Or is it easier to go to the finance industry, or is it easier to go to the finance function or the marketing function? Like,
Sure.
Is there any difference, or is there not even?
There are some differences. Some of the departments use their data traditionally to make their decisions. So they're already familiar with some of these concepts, how to use the data, how to create a dashboard. So, for example, you already mentioned the finance department. They're already using the data in their own mind to create different kind of reports. Also, marketing departments also using the data in some fashion to understand what customers want. So basically from that perspective, really, it's easier to work with some people rather than the others. Going back to your quick win comment, definitely the best possible way to engage with the business partner is through some kind of visualization. And that's it's kind of in direct opposition to what I said earlier, that we are trying to change that. But in order to create that kind of quick win, is always the best to actually create some kind of quick dashboard. We always keep in mind that we don't create the dashboard just for the sake of dashboard. We also keep in mind that this dashboard would not be just to report certain things. We don't create reports. We want to use this dashboard to provide recommendations. So basically, by using this, we are trying to actually educate the business as well, while we are providing what they initially asked. So this is the best way to engage with the business, create the commitment on their side and dedication. Because in my opinion, number one reasons why 95 or 90% of analytics projects fail, this is according to several surveys, that 80 to 90% of analytics projects fail, is lack of commitment. Because people treat data analytics people more like IT. They give them specifications and they expect results. But that's typically not how it works. It's usually iterative process. You have to go through different iterations. Data science or data analytics is not simply straightforward. It typically requires a lot of going back and forth with the business and trying to make sure this is what they need and that's how it works. You cannot guarantee, for example, that your prediction model will have 90% of accuracy. Everything depends on the data. So that's why it's not the same as IT or software engineering. And that's why you typically requires extra more time working with the business and making sure they properly adopt the model, they properly use it, and they properly quantify and track their metrics.
Yeah, nice. I love all those insights. I would like to just dive into some machine learning and AI, because a lot of our listeners are probably more on the just analytics side of things, like they haven't ventured into the data science. But I feel like there's this democratization in the advanced analytics happening right now, and that sort of analysis is becoming more and more accessible to even your everyday analyst who might have been an Excel user historically. They've maybe graduated to building in Tableau and Power BI, and now there's an opportunity for them to explore machine learning and AI in some form. Not the advanced aspects of it, but some of the more achievable aspects. And so I was wanting to understand more about how you go about educating those around you in terms of what's possible, because I find that is actually half the battle in a lot of cases, is that everyone just doesn't have the imagination to think, well, what can I gain out of exploring this avenue?
Yeah, I think that's one of the few things that we try to do, building that kind of data-driven culture, trying to educate the business what is the art of the possible of analytics, exactly what you mentioned. And this is, again, the key, trying to change that mindset. So what we're trying to do is organizing few workshops. We actually use the company called Data Robot. They have a training called AI or machine learning for executives. We try to actually organize series of workshops like this, where we can try to present the concepts of AI and machine learning, mostly to business executives, to show them what actually machine learning really is, how they can associate machine learning with them, and how they can start thinking from the analytical perspective. For example, we try to use particular use case or particular problem they have and try to convert or twist that problem so we can use analytics. Part of that workshop that we're trying to do or that training is actually going through the use case they select. We kind of split the audience into several groups. We try to actually work with each group on particular problem they have, business problem they have, trying to see what particular data is available, how they can apply analytics, and what are the key metrics they need to quantify, what kind of key metrics they need to track, and how they can estimate the entire value of the project. So this is one thing that we're trying to do. We're also trying to actually provide the tools like Data Robot or Alteryx or other tools that can be used for data science democratization. So the business people can start playing with the data through the kind of environment that we have. Tools that will enable you to play with the kind of the blocks instead of actually trying to code. And people can feel the data. Once you feel the data, you will start thinking in a slightly different direction. And if you start visualizing some of the data through some kind of simple concept, providing the histograms, providing the different distributions, trying to see what are the most common value, people will start understand what's happening in the data, and they will kind of keep working with you in more proactive fashion. So that's the second thing to do. And the third thing, we are trying to also internally organize the different learning sessions when we educate the business, how we solve particular problem that is of relevance for them. Not necessarily teaching them what particular technique is. For example, they can use, other open source code for that or learning platforms. We actually also have engagement with Coursera. so people can learn, for example, what the basic data science courses are and everything. But you're not necessarily trying to teach them basic technical things. We're trying to see how they can apply some of these machine learning techniques for some of the common use cases that are basically applicable to many of the business partners we have. So these are some kind of the things that we are trying to do. And I think it's working relatively slowly, but it's working.
Yeah, nice. I think that the way that I think is data literacy is that there's this huge demand for more of it. From not just from those who are familiar with analytics. It's sort of like the entire business. You want everyone to become more data literate.
Yeah, and I think there are companies and organizations, especially mature organizations, that have a special role, a specific role that would be just data advocate or someone who will be responsible just for training and building that kind of data driven culture. I think this is important role that could not be ignored. And sometimes if you don't have a dedicated role for that, you as a leader or your people have to take responsibility for that as well.
Agreed. Totally on board with those thoughts. Data Robot is an interesting brand that I've seen around, but haven't actually dived into so much. Do they provide sort of prepackaged machine learning models? Is that sort of the offering that they have?
Yes, pretty much. So basically, Data Robot will enable you to do some kind of automation of building predictive models. You will start with the data set that you load into the system, and the Data Robot will run a series of predictive models, machine learning models, sometimes even hundreds of the models, without need for you to actually hyper-tune some of the parameters. Data Robot will run all this hyperparameter tuning in the background, and it will provide you the best results without actually need for you to understand how any of these models work. Sometimes this is good, sometimes this is not good. It's good from the perspective that you will be able to find the best solution from the perspective of the data that you have. Sometimes it's not good because you believe, or your data science background, your experience will tell you that certain model may work well regardless of the data that you have. It doesn't give you a lot of flexibility, but sometimes you also can dive in and change some of these parameters. It also allows you to deploy some of these predictive models automatically, and actually business can use them. One kind of drawback of the current model, and actually any generic data science tool, is actually that the process of feature generation is not automated, and sometimes this is a little bit more complex. It typically requires a lot of background, the knowledge, domain expertise, and how some of this domain expertise could be converted into more successful features. Because in my opinion, the best feature that you can use in your machine learning models is typically how you incorporate some of that domain expertise into the feature that could capture particular aspects of what you're trying to predict. And that's something that is not easily automated.
Can you give an example of how you bring those two things together, the sort of technology, but then also the domain expertise? Because I think that'd be really useful.
Sure. So typically, how these automated feature generation tools are working, they are typically trying to actually change several parameters when they try to generate a feature. For example, when you're doing a credit score modeling, the feature that may be of interest, number of, let's say, inquiries in the last 6 months, 12 months, 24 months. So typically the models will change this parameter 6, 9, 12, 18, 24. And this is how you will generate a lot of features, and they will try to find which one is really at the best. However, what you're trying to do is try to see how, for example, if you're talking about the credit modeling, let's say you're trying to predict what is the credit score for a particular consumer. You're trying to understand how particular information of your credit report is related to credit score and how much you will be able to pay for your loan. What you're trying to understand is really how, and I'm trying to figure out the right example here, how particular feature is correlated to the loss that you may have a loan. You may have, when you do the modeling, you will start from the data that will have information, potential defaults on the loan versus information on the credit report. So you are trying to establish the correlation between particular information on credit report. So let's assume utilization rate. Utilization rate is defined how much money you are spending versus the credit limit you have. So, for example, if you have your credit limit is $10,000 and you're currently spending on a monthly level, it's only $1,000. Your utilization rate is only 10%. So basically, being able to define that utilization rate and see how that utilization rate is connected to the loss, it's one of the features that really actually requires some of the domain expertise. This is not something that just feature generator will be able to drive immediately. You have to think about particular key metric, define that metric, and then you can play with this. So this is maybe one example. Maybe it's not best example, but it shows you that you need to define some metric that requires some kind of domain expertise, and that will help you capture some of the information regarding the target variable you want to predict. Sorry, I went too technical, but this is what
I think that makes complete sense. I mean, the way I think about it is that, okay, you can, let's just say, pre-COVID, you put the last 10 years of data into around that sort of credit scoring model. You put the last 10 years worth of data. Well, the model is going to spit out metrics or predictions that are going to say that the default rate is quite low. But that's because it's only seen 10 years of expansionary economic growth. Whilst someone with domain expertise is going to say, well, hey, look, you haven't factored in maybe a down cycle in the market, and that's where that experience is going to be exceptionally relevant, because the model is not taking into account all of the available information it could. I mean, you really need 40 years of data to sort of see the ups and downs.
And also, since you mentioned COVID, very often people who were doing different kind of predictive models, immediately after COVID, they found out that not much of the data was relevant, and they have to figure out actually what to do. We experienced similar problem for demand forecasting, just to connect what I mentioned earlier. Much of the data, when we're trying to predict our demand for our particular customers, we couldn't use the data for the last, let's say, 6 to 12 months, because the data was not relevant. The conditions were completely different. The data we had in the past were really not relevant. Any kind of seasonal effects, anything was completely distorted by the new epidemic, but the new data, the drop in the customer confidence and everything. So we basically ended up using different kind of external data, trying to see whether financial and economic indicators would be a good indicator what is happening in the future. And actually, we were partially successful there. So basically, some of this data helped. And I think this is something that data scientists always have to do. If the conditions are not the same, they have to find relevant information, relevant data, and see how they can adjust their predictive models in order to make it relevant.
Yeah, I think that's interesting, is that you've got to be versatile, you've got to be flexible. You can't just rely on one model all the time. You've got to always be tinkering with your with your product, with your output, to make sure that because at the end of the day, a lot of machine learning and predictive analytics, I mean, a lot of it is predictions, right? It's like there's no certainty in all of this. It's really just trying to give you a better decision-making tool than what you have maybe had with just your intuition in the past.
Yeah, and one important thing just regarding that is to always keep to track your prediction model or to monitor prediction model from the perspective whether it's performing from the perspective you expect to, whether it's giving you results that you expect to, and whether any kind of shifts in distribution. For example, in the COVID example, if you monitor your model, you will definitely see the shift in distribution in the data, and you will see that your model is not performing as expected. So it's basically a sign for you that you have to change something, and actually you start looking for solution. And that's absolutely the key for any kind of deployed model or the model that you put into production, that you keep doing this, because that's the only way that it will keep producing the value for your organization.
Yeah, nice. Now, just to jump over to something else, you've written a book, I believe, and also a number of articles. Can we can you give us a bit of an outline around what those have focused on? I think this would be a good chance to plug some of your historic work, and then we can maybe talk more about some of the unique insights that you've been able to bring together with these projects.
Sure. I mean, I stopped publishing probably like 5 to 10 years ago. Most of my articles were from the time when I was a PhD student and after I completed my PhD for the next maybe 5 to 10 years. My PhD thesis was in the area of combining different predictive models through ensemble methods. This is how it's called. Most popular techniques in that time were bagging and boosting. You probably heard of terms like ADA boost, gradient boosting. All of these techniques were part of my research when I was a PhD student, and most of these articles were related in this area. When I started my first research position, I was working at the Army High Performance Research Center at University of Minnesota. I started to do a lot of work in computer security and network intrusion detection using machine learning. So a big portion of my articles is in this area as well, how to use different machine learning techniques, especially anomaly detection, to predict different kind of intrusions in the network, as well as to predict the fraud. And my book is actually regarding how to use machine learning to predict the computer intrusions fraud. So that's the book about, and most of my articles in one of these areas. This knowledge was extremely useful for me when I got my job at Aetna, when I was responsible for healthcare fraud, waste, and abuse detection. And we tried to leverage many of these techniques and papers. And actually, we end up doing pretty good from that perspective. We detected a lot of fraud that was happening in healthcare space.
Nice. I think anomaly. I like the idea of anomaly detection as something to dive a little bit deeper into, because I think this is something that has a lot of relevance to lots of different aspects of businesses, right? But is not something that is focused on at all. Like it's one of those things where I think you need some imagination in terms of like what you can actually do in a lot of cases. So what like how in the past have you gone about anomaly detection projects? Like how have you like have you basically just fed raw data through a particular model, and then it, with a bunch of parameters, and then it just says, here are the anomalies, or like is there a bit more to it?
Yeah, I think you have to be extremely careful when you decide to apply anomaly detection in any real life project, because typically you end up applying anomaly detection if you don't have any other choice. For example, if you have any kind of label data, you can easily build a predictive model, supervised classification model to predict, for example, fraud. Let's take example fraud. Let's say you are trying to predict the credit card fraud, and you try to predict which transaction are fraudulent and which are not. So if you have, examples, which transaction is fraud, which is not, you can build a classification model, and that's much easier job. However, if you're starting really from the blank plate, you don't have any labeled information, you just have a bunch of transactions, and you actually start building what may be fraudulent, what is not, you have to be extremely careful. Typically, in anomaly detection, you treat all deviations from majority of behavior. Majority of behavior, you assume it's a normal behavior. So you treat all the deviations, so outliers from that behavior, as potential fraud or potential suspicious activity that you want to detect. However, in that process, you always have to rely on a human being. So in every anomaly detection problem, you have to work really closely with your business partner, someone who is expert in this field, to verify some of the findings you have. Anomaly detection will not always detect the things that you want to find. It will detect deviations. And sometimes these deviations are useful. Sometimes these deviations correspond to different errors in data. But again, most of the time you would like to know about this behavior, whether to correct the data errors, whether to correct some behavior which is not necessarily fraud, and sometimes how to detect a fraud. So the key aspect of anomaly detection to work really closely with experts who understand the data and who understand the business problem.
Yeah, nice. And do you find that sort of analysis is being totally underutilized, or is there? I mean, this could be the same for a lot of machine learning and AI type analysis as well. Like generally, are you finding that there is an awakening out there, especially in the business units that you deal with, in terms of like what is actually possible? Like, is the imagination and creativity growing out there in sort of the business user space?
Yeah, I think there is more and more interest of using anomaly detection in particular fields. I think mostly in financial industry to detect different kind of fraud, whether this is credit card fraud or money laundering. It can be used in healthcare industry to detect the different kind of variations or to completely new emerging types of fraud. And you can also use in computer security as well, because very often when you have like a McAfee vendor or you have a Norton antivirus typically captures what is known. So it can only detect the known viruses. Every new type of behavior may not be detected with that kind of pattern signature or the signature of the virus. So companies like McAfee, Norton, even some healthcare companies started to implement a lot of anomaly detection techniques to detect different kind of suspicious activities. And you typically provide some kind of score that will reflect your confidence how much certain activity is anomalous or not. You typically try to rank these activities based on that score and provide maybe only top of these scores to the human analyst or someone that is using that software or is looking at these results. But there is definitely increased interest of people to use anomaly detection, but it's in my knowledge, actually, most of this is always associated with some analyst, some human expert, or someone who is really has a lot of data knowledge or business knowledge.
Interesting.
But there is increased interest recently to start leveraging more anomaly or outlier detection.
Yeah, it seems like it's almost inevitable, right? Like as the technology is becoming easier to use, more accessible, cheaper, like all of these things are just continuing to, the trend keeps continuing, right? And it seems like it's just going to happen more and more and more. Well, one thing that I think also would be interesting just to jump back to is sort of, within a large organization, a large conglomerate, what do you think is, maybe based on what you have currently sort of set up within the business, is like the most optimal structure around how you build out your analytics resources? Like, is it better to have some sort of centralized center of excellence and then have a self-service? Is it better just to centralize everything? Like, what do you think is the best strategy around that structure?
Okay, so in my opinion, everything depends on the kind of status where your organization is with respect to data-driven culture. In my opinion, there are three different types of companies. Companies who are purely big data companies like Google, Amazon, Facebook, Microsoft, who are really driven by the data and who make every decision based on data. The second type of company is like financial institutions and maybe insurance companies who were using the data previously from the perspective of pricing, from the perspective of understanding the customer's claim analytics, or some kind of claim statistical analysis. Companies who were using statistical analysis before using some kind of data. And the third type of company is everyone else that traditionally didn't leverage the data to actually implement any data-driven decisions. And this range is really from retail to healthcare to manufacturing. And depending on which kind of organization you are, different kind of organization for your analytics efforts would be appropriate. For example, if you are in the first time of the company, when it's completely data-driven company, then you may have analytics teams within every of these business units. So this kind of decentralized model may work pretty well because you have built that kind of data-driven culture. On the other side, if you have kind of data-driven culture that is not mature yet, and you're starting to build data-driven culture, there is not awareness of what the art of the possible analytics. Centralized analytics organization is probably more appropriate. That organization will start building that data-driven culture, will start increasing awareness, and actually slowly, when people have more data literacy, when people can apply more analytics, you will actually start building a data-driven culture, and slowly your centralized analytics organization can have pockets within the business units that can work very closely with your organization and it can drive the impact. That's how I perceive that should be done. In my opinion, that's the best way to actually build the whole analytics effort across the whole organization and drive the impact from the analytics.
I really like that framework. It seems like there's no one answer there, right? It's better to think of it like, where are you on the data maturity curve as an organization, and then structure your analytics resources around where you're at. So I think that's actually a really unique insight that we haven't had before.
Yeah, I think data analytics is a relatively new field. I mean, only 5 to 10 years. And that's why there are no best practices yet. There are some good practices that may work for a particular type of organization. And everything depends really of the culture. And everything depends how people will perceive that. And actually, that's how you have to play the role of the chief data analytics officer and actually how to drive that engagement across the whole company.
Mm-hmm. And from your experience, like what, like, are you guys on sort of like the self-service part of the maturity curve, or where do you feel like you're sitting at the moment?
We are somewhere maybe in the 2 to 3 years of building that kind of data-driven culture. We still have a centralized analytics organization. Some parts of the entire Stanley Black & Decker may feel that have enough exposure to the data, so they can start building particular dashboard by themselves. And actually, that's our goal, to provide data to everyone, so they can start playing with the data. They can. Actually, our goal is to give them the tools, and so they can actually start creating the dashboards. Our goal was never to create a dashboard just for the sake of the dashboards. It's always actually thinking the step up to that. And actually, we are probably 3 to 4 years into the whole process, and maybe 2 to 3 years before that kind of fully decentralized model can be created. Somewhere in the middle, that centralized analytics organization is still playing important role, how entire data-driven culture could be placed, or actually could play out. Right. I think we are in the process when we can prove the value by doing short-term project, small analytic use cases. We prove the value, we prove the credibility, we actually earn the seat at the table, working with the business to create their business strategy, so we can start working together how to actually define the strategy for each of the businesses and how to use analytics from strategic point of view. But we are not at the level when all of these business organizations can have their independent analytics teams to drive the value, because I don't think there is enough analytics awareness yet within these organizations.
Right. Is there any other ideas that you have or that you've seen successfully implemented to drive a data culture faster, like to get everyone more immersed into making decisions with data? Is there anything, any ideas, any tips that we might not have touched upon?
I cannot think of anything right now. I think the key things is, again, giving the data to people, access data. You have to be careful to follow the company rules. You cannot give the data to the production service, because that's a big no-no. It disrupts everything you do. You have to build a separate data environment that people will play with the data, explore the data, understand the data. You have to basically give them an opportunity to learn a little bit more about analytics through the different kind of things that I mentioned earlier. And actually, you can work with them how to slowly shift their mindset, thinking from descriptive or more like diagnostics perspective, what happened in the past, versus how we can drive decisions in a better way. So I think that's a major shift that you have to do. And that can be extremely difficult depending on the organization that you're in.
Nice. Okay. Yeah, I like it. It's a nice, simple way to think about that sort of aspect of enhancing or generating value from your data assets. Absolutely. Okay, so final question, or a more open-ended one, I think, as we sort of round off. Like, you've had some great exposure to the growth of this industry, right? Especially in the advanced analytics space. And I was just wondering where you see things going from here. like we have talked about sort of the democratization of sort of machine learning and AI and predictive analytics, etc. But is are there any other trends, or do you see things happening in around that space that maybe not everyone is aware of?
You mean like a general
Yeah,
state?
just generally. I mean, like, it's been amazing how far the analytics area has come,
Yes.
right, in the last sort of 5 to 8 years. I mean, it's just unbelievable. But I'm sure there's much more to go. So I was wondering what you think about that.
That's the beginning, and I believe it's just the beginning. So I believe there are probably a few major trends. First, it would be continuation of cloud being present as a major data platform. Really, I think there was a survey by or report by Gartner in October last year that by 2022, public cloud services will be essential for 90% of all data analytics innovations. So there will be still cases where you need like a private data environment, but this would be mostly focused on use cases when you need probably highly computational expensive calculations, because the cost of public cloud may kill you there. So you may need to consider something your own. But most of this data analytics will actually move to the cloud. That would probably mean that many data analytics leaders have to think how to actually consider data governance, data management, how to move the data from their existing legacy systems into the public cloud infrastructure. That would be a big problem, a big challenge for them. How to properly organize data management, data governance, how to create this kind of data stewardship role more apparent or more actually prominent across the whole company, because data stewardship role would be extremely important as a bridge between the people who are holding the data right now and the people who are trying to use data analytics. I think that's the biggest probably trend, or actually continuation of the trend, I would say. I think the second one is there was probably tendency so far to separate companies that focus only on big data, data management, data governance versus companies who focus on machine learning and AI. I think there would be probably a tendency to merge this together and have some vendor that will provide the overall solution. And I believe probably some consolidation in industry may happen due to this space, because if you have a company that can offer you everything, you would rather choose that one than to choose 5 different vendors. I think probably that will be tendency to some company to acquire other companies to expand what they offer to the customers. That's probably one of the trends as well. I think there is a definitely trend towards, as I mentioned earlier, towards automation of machine learning and AI to actually have less coding for the people who want to use, and that's mostly towards that kind of data science democratization. There will definitely be shift from this kind of dashboard thinking towards more like AI and machine learning thinking. And I believe there will be a proliferation of different kind of deep learning or AI-based use cases that would drive the decisions. For example, self-driving cars is one example. How to actually use deep learning to automatically recommend the products to our customers. These kind of examples. Or chat-based or actually AI-based conversational agents. So, for example, when you go to the website, you will have an AI algorithm that will chat with your customer versus a versus real-time person. So these are kind of the trends that will happen. Actually, more comprehensive AI and machine learning will also take place as well. I think these are some major trends that will probably happen in the next few years.
It's amazing when you go through those things. Like, a lot of them already exist, and we're just so immersed in them, like Netflix and Amazon and Google Maps, and like even I get these analytics emails from Microsoft Outlook saying how I've like used my time in my email. I mean, all of these big players are already so immersed in it, right? Like it just feels like it's just gonna keep filtering down to lower and lower levels. Like you might find that like every Shopify store, no matter how big you are, will have some sort of recommendation engine that they can plug into, like something like that.
Yeah, true. But I mean, The biggest trend, not necessarily to data analytics, in general for every industry, is understanding the consumers, because there will be definitely more focus on the customers. That kind of rise of consumerism is inevitable. Many companies, in order to survive, will have to understand their customers. Will have to actually, it's not a question anymore whether you use analytics. You have to use analytics to survive. Basically, the question would be how much data you use and what kind of relevant data you use to actually drive proper business decision. And I believe the customer will be in the center of it. You have to understand your customer better in order to provide better services, regardless who your customer is. And I think understanding your customer would be the key. And actually, many companies will start selling the data regarding customers, regarding everything. So that will help different companies to build better product and better services.
Yeah, I like that. That's a good one. Okay, Aleksandar, why don't we wrap up? I think we've gone through a lot. That this has really flown by. I've really enjoyed getting into more of the advanced analytics topics that we haven't really covered so much on the podcast. So I really appreciate your time today.
Thank you very much, Sam. It was my pleasure to be here, and we can continue anytime.
Yeah, I look forward to having you on again. I think there's some really unique insights that you've been able to share with us today, and I'm sure there's far more, but we just time constraints, have some time constraints today. So, well, thank you everyone for tuning in to the podcast. Make sure to subscribe and leave us feedback on your favorite podcast player. Thanks once again, Aleksandar, and take care, everyone. Okay, talk to you soon.